Well, welcome everybody. Now that it's 4:01, I guess we can start for real. And this week we're dealing with measures of center, which is basically, the three that we've probably already heard of. I think you all know what the mean is, right? It's just the average of something. You've probably heard of the median. It's just the middle of your data, and you have to obviously first sort your data from smallest to biggest, and then you find the number that is literally in the middle of your data, right? Half of the values above, half of the values below, and that's your median. And then the mode is just the most common data value. And just realize that there can be more than one mode. It's the only one of these three that can have multiple answers. So for instance, if we have a data set like this one, the first one, the mode is 8 because it shows up 3 times, right? And then down here, again, the mode is 8 because it shows up 3 times. But if we took one of these away, because it's really stupid that this example is the same both ways, so let's make this example better. Now we can see that there are actually 3 modes, 6, 7, and 8, because they all showed up twice. Now, if I put another 9 in here, what are the modes?
6, 7, 8, and 9.
Thank you, Jacqueline. That is a fantastic guess.
That
And
was
the
an
guess that
easy one.
and it's actually wrong. That's why I do this, because
Okay.
everybody
It
thinks the
felt
same
too
thing.
easy.
Yes, the mode has to be the most frequent. Since they all have equal frequency, even though that frequency is 2, there is no mode in that data set. Okay, so it's a very common mistake, and it's why I do this example, because I want to get at those misconceptions that everybody has. They think that just because they show up multiple times, they're a mode, but no, a mode still has to be the most frequent, and in this case, they all have equal frequency. So that would have no mode. Okay, let's see, what else do we have? We've already talked about frequency distributions. They're just ways of telling you how often things show up. So you can see very clearly from this frequency distribution that your mode would be 2, right? Because it shows up 5 times. If you have data that are in classes or bins, right? Then you can still do frequency totals with those. And then you can see here that the class 50 to 60 would be considered your mode. And usually what happens with this kind of data is people will report the midpoint as the mode. So let's say 55 is the mode, which is horribly inaccurate, because we don't even know if 55 exists in this data. We just know that there were 10 numbers between 50 and 60. So, if you're going to deal with binned data or data that are in classes, that's fine for coming up with frequencies, but I really wouldn't suggest using the midpoints when it comes to doing other things. Like, people will take the midpoint of this, which is 25, multiply it by 5, get a number. The midpoint of this, which is 35 times 8, right? 45 times 9, and basically do a weighted average that way and get the average of your data. Terribly inaccurate. Now, obviously, it's the best you can do if the only data you were given, right? If you didn't actually have the raw data and you only had this information, then you can do those things to get an approximation. But just realize that those approximations can be horribly, totally wrong. So yes, it's your best guess, but your best guess is actually really crappy. So it's kind of one of those things that I like to tell people: stop trying to force a square peg into a round hole. If you have this kind of data, just just give up. Just realize you've got crappy data. You can't do anything with this data other than report frequencies. Don't try and do things with it that you really shouldn't, like computing means and computing medians and computing modes. Now, you could, again, report that this interval or this class is the most frequent, but you can't say that 55 is the mode, right? You can't talk about the median by going, okay, there's 40 things. So if I count these up, 5 and 8 is 13. 13 and 9 is 22. I know that between 20 and 21 is where the median lies. And since this set has 20, 21, and 22 in it, then I know the median is somewhere between 40 and 50. That's all I can say. I can't say the median is 45 because, again, that's taking liberties. That's taking huge liberties by just using midpoints. So just don't do sloppy, crappy statistics. If you have crappy data, then just give up. Just only do what you can do, and don't try and report extra crap that you really shouldn't. So, frequencies, we've seen it before. It's usually done with what are called nominal level data, right? Or just words, things that aren't numbers, because then that's about all you can do with these things is count up how many you have. And this is the only difference here is this is kind of like a two-way frequency, right? Where it's the data is classified two ways. So it's classified both by how they live and the year they are in school. And this is actually a very common table to see. Sometimes it's called a cross, right? Cross table, or a cross frequencies table, or a cross tabulations. I mean, it's got a bunch of different names, but it usually has cross in it somewhere. And it's just because they cross, right? You got horizontal and vertical kind of crisscrossing. Very popular display for data that can be categorized more than one way. Standard deviations talk about the spread of your data. How widely spread out is it? So obviously this thin curve, this normal curve, right, this thin distribution has a small standard deviation, whereas this wider one has a larger standard deviation. The area under the normal curve always equals 1, so these two curves have the same area. That's why when you make it thinner, it becomes taller, and when you make it wider, it becomes shorter. Now that's only if those are true normal curves, right? Then their area is 1. I mean, you could have something else that doesn't necessarily have an area of 1, but any curve that represents a probability distribution will always have an area of 1. Okay, standard deviation, examples with small standard deviations would be the price of the same model of new cars, because there's not going to be a huge variation. Although now with, all the different options, you could get a pretty big variation on, a certain model type just based on the type of extras you get, I guess. Heights of 30-year-olds, that should be pretty small, right? Because by the time we reach 30, we should all be done growing, and we should all be roughly, at the average height at that point. Some of us will be taller, some of us will be shorter and stuff like that. Whereas the heights of 7th graders would be much more spread out because, girls usually grow faster than boys early on, and, and then there'll be different kids to have growth spurts. So heights of 7th graders are just going to be all over the place. And then, of course, price of the same model used cars would have a bigger standard deviation because it all depends on their condition, right? If they're in crappy condition, less, in really good condition, higher. So you're going to get a much bigger variation in prices than you would if you were just looking at the price of new cars that had obviously the same model. Okay, now the coefficient of variation is something that enables us to compare standard deviations between two different sets of data, because the problem with talking about large standard deviations and small standard deviations is they're relative to the size of your data. So for instance, if we're talking about the weight of mice and the standard deviation of them, well, the weights are small, so the standard deviation is going to be a small number. Cecily?
Yes,
Cecily?
my question was actually back a few slides back when we were talking about the modes, but we can, if we need to wait before we
Nope,
go
that's
back
fine.
there.
I'll go back to the modes.
It was actually that slide right
This
there.
one?
Yeah. So when we were talking about when you were mentioning the frequency distributions and how this should not be utilized to determine the mode, is it possible, and if I remember reading correctly, that say the interval of 50 to 60 then would be the modal interval, but not
Yes.
necessarily the mode?
Yes, that would be an accurate statement.
Okay.
Absolutely. Yes. And it would also be true to say that, the median of the data lies somewhere between 40 and 50.
Okay. Alrighty. I have a couple other questions later, but
Okay,
oh,
great. No,
thank you.
you're fine. Let's see. So back to the coefficient of variation. As I was saying, if we were looking at the weights of mice, they're in grams, and so small numbers, and their answer is going to be small. It's going to be probably between 1 and 10. It's going to be a single digit number. And then if we talk about the weights of elephants, which are in hundreds of pounds, even I think they're over 1,000 pounds. Then their standard deviation is going to be much bigger. At least 3 digits. At least probably in the realm of 100 to 150, that kind of thing. So when you look at the difference between those two groups, you go, wow, a standard deviation of 3 for mice is a much smaller standard deviation than 150 for elephants. Well, not necessarily, because yes, 3 is a smaller number, but if we looked at their distributions, this might be mice all spread out, and this might be elephants all clumped together. The only reason why their standard deviation is 150 is because the numbers are bigger, and the only reason why their standard deviation is 3 is, again, because the numbers are smaller. And so in order to truly determine which one has a wider spread, so which one's distribution would look, more like this and less like that, so to speak, is to do what's called a coefficient of variation. What it does is it takes that standard deviation and it normalizes it against the size of the numbers in your set. So what you do is you just take the standard deviation and divide it by the mean of your numbers, and then it gives you a number that's more comparable to something else. Because it's by dividing by the mean, you're dividing by the average, right, size of all of your data values. And so you're figuring out basically how big is the standard deviation in terms of the mean, i.e. in terms of the average size of your data. And you go, okay, well, this standard deviation is, a little bit more than 25% of the size of the mean. So it's kind of like 25% of the size of your data values. Whereas the elephant, which had a smaller number in this example of 1, because they were doing it in tons, is 45.5% of the average data value. So much more spread out. So in this case, the elephants would have a bigger spread than the mice. So, if we were looking at the graphs, the mice would look like this and the elephants would look like that. But it's not because the elephant's number was bigger. 1 ton is a bigger number than 2.4 grams. And it's also not, has nothing to do with the number 1 being smaller than 2.4. It's not about the size of the numbers. It's about their relativity, right? So it's that number divided by the mean of its value of its data set. And that's where we get coefficient of variation. So it's, like I said, it's just a way of figuring out how to compare coefficient or standard deviations between two groups to see which one really has the bigger spread, right? So when something comes out to 20% versus 33.3, you can see that this one has a larger spread. And when you're talking about investments, a larger spread means more volatility, right? You have more opportunity for growth, but also more opportunity for loss. The numbers are going up and down in bigger intervals, and that's why you're getting a bigger standard deviation. This investment might not have as large of a return, but it's going to be steadier. You have less chance of losing all your money, so to speak. And those are all of the big ticket ideas that we are supposed to learn this week. So I will now open it up to questions. If anybody has jumped on the homework, we can discuss some homework questions.
I have a couple. I don't
Go
know.
for it.
Yeah.
Like, where do I start? Let's start with an easy one.
Okay.
3.24.
Okay.
don't know if I can share this. So I have that there's multiple modes on the second and the third group,
Very
but when I
good.
ran it, it only put the one mode in the top
Yes.
chart,
So
and then at the bottom it has like 1.55, 1.57. I don't know if
that's fine.
that's okay the way it looks.
Yeah, that's
Okay.
fine. If you run summary statistics in SAS, right? So this is, darn it. What is it? Pie charts 3.24, this one. So if we go to SAS and we go to our files and we load 3.24, right? Double click on it, bring it over to this side, and then run it. So we actually load it. I always like to look at my output to see what kind of stuff I got. Okay, a group, a city, and a rate. Okay, fantastic. And then you go to your summary statistics. So under tasks and utilities, you go to tasks, statistics, and then summary statistics. I'm going to double click on that and then tell it, nope, I want the import that I just brought in. I go to my options and I want the mean, right? And what else did it ask for? It asked for complete the mean, median, and mode for the three groups. That's all I want, is mean, median, and mode. So let's turn off all the rest, right? So I don't want standard deviation,
I have
minimum,
another
maximum.
question too. I unchecked that number of observations, but it still keeps showing up.
Yeah, I think number of observations might show up
It
just
keeps saying 10 in a column there, and I can't seem to get that out either.
yeah, and that's fine. It just depends
Okay.
on sometimes it does that, I think, because it's kind of a default to let you know how many observations you had. So I don't, if that's the case, I don't know why they let you unclick it. You know, why
Uncheck
is it
it.
even
Okay.
why is it even a thing? Okay, so why is mine not letting me run it? I don't think my data is right. Oh, because I have to choose a variable, dummy. So my analysis variable is obviously the rate, and we're going to group it, right, by the group. And then now let's run it, see what we get. So yeah, you're right. Number of observations is there no matter what. So there's your mean,
Okay,
median,
I thought
mode, or
it was
why did it
wrong,
still
but
give me
it's
minimum? I thought I
printing.
turned minimum off. But anyhow, there's your stuff, and it only lists one mode. Group 2 has 2, and then if we get rid of this and run it all at once, you know, all as one big thing, there are actually 3 modes here. So the only way to get it to do that is to use the code. Yeah, so if you put this code in there, it'll show you all of the modes when there are multiple modes.
Okay, and it just showed it below in like a different box. That's okay.
Yeah, that's totally fine.
Okay.
Mindy? You have a question?
Yep, I do. Can you hear me?
Yeah.
My question is there a way to do a stem and leaf plot in Excel? Like based off that problem, because there's 3 plots.
I don't think Excel can do stem and leaf plots, actually.
I watched a video where they could do it, but they only did it with 2. They did it back to back.
Okay.
But I
Well,
just, if there was a way to do it, and I just didn't know it.
There might be. You can Google search it. I mean, there's pretty easy to do it in SAS by just using the code that I have listed here in the how-to document.
Okay.
I'll show that next. Cecily?
I'm sorry, I'm trying to make my notes here. Yeah, I'm gonna have to go back. I got frustrated with SAS, and I'll be honest, I forgot that you had this document with the codes. And started doing some of this in Excel.
Okay.
One of my concerns, though, that I found was, well, actually I have 2 questions. Let me finish with this one. One of the concerns that I found was when I was doing the histograms, they wouldn't look like the ones that SAS generated.
Oh no, they won't. Yeah, SAS and Excel have hugely different graphics interfaces, so their graphs and plots and all that stuff will look terribly different, which is totally fine.
Okay, because my concern was I didn't want that to be the reason I was marked down on my homework.
No, I
Um,
don't care which technologies you guys use. I just want you to try and make the graphs look as close to what the instructions say, right? So if it says, make sure your histogram has 6 or 7 categories, make sure it has 6 or 7 categories.
right.
You know, and if
So-
it's asking for a histogram, make sure it's a histogram, i.e. that the bars all touch. And if it's asking for a bar graph, make sure it's a bar graph, i.e. the bars don't touch. You know, it's those kind of things.
Okay, that makes me feel better. But back to something you just mentioned about intervals. And let me go back to the text here. In one of the examples, and now I can't remember which one it was because I don't have everything pulled up. It was, we were supposed to use a set number of intervals. And I had an issue trying to make it work with the selected number of intervals. And when I went back to the text on page 71, in the example that they gave for table 3.6, they stated that they were using 10 intervals. However, when you look at the table, they have 11 classes or intervals there.
Could be a typo.
Now, when you do the math to determine the width of the interval, it is 10. So I guess I'm lost because even when
Are you sure the 11th interval wasn't like another, you know, just kind of a throwaway interval? Because they do that often.
No, because their largest the largest measurement fit in that interval. Here, wherever, this is my notes. Okay, on why did I not write this down? I'm sorry, I'm trying to figure out which. Oh, it was on 3.54.
What's our book?
Oh, our book is what is?
Isn't it this one? Introduction to
yes.
Statistical? This one?
Yes.
Okay. All right. What page are you on?
71.
Okay. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, they sure have 11 classes.
Because if they did 10, then the largest measurement would not fall into the 10th class. And I had that same issue.
Which is probably why they did it, right? Because let's see, where do they start? Dividing the range by 10 and rounding to a convenient number, we have 2.5. Where's their range? Oh, there it is. The range is 25.
Back to page, to table 3.5, page 70.
Yeah. So I think the reason why they did that is 2.5 became a convenient class width, but when you run it out and do, you know, starting with something that's small enough to capture the smallest number, like you said, the 10th one didn't capture the largest number, so they had to augment it that way.
So I had that same issue with question 3.54. And initially I was doing this in Excel. I'll be honest, I have not had a chance to go back and work it in SAS. But I actually now found my notes. I started doing some of this by hand, doing math by hand here, of trying to make this work with 6 intervals or 7 intervals. And I had the same issue where the largest measure would not fall into the 6th or 7th interval. With that said, I also, I guess, didn't quite understand the determination of the starting point of your first interval. There seems to be some
Yes.
arbitrariness
Yeah.
to that.
Okay. So I think let me step in. I think I can clarify all of your questions with
Okay,
saying
thank you.
a couple things. One is none of this matters. Most important thing to realize is that you, as the person who's in charge of your data, can do whatever you want to it in the real world. You can have 5 classes, 7 classes, 10 classes, 3 classes. You can start your lowest class at 10. You can start your lowest class at 15. You can have them as wide or as narrow, whatever you want, as long as it shows all of your data, right? I mean, as long as your classes span the entire range of your data, that's all that matters.
Okay.
Now, as far as what the book is doing and showing its examples and all this and all that, yes, there's a lot of variability. But the bottom line is the reason why that variability is there is because they leave it up to the steward of the data, i.e. the researcher, the publisher, right? Whoever's going to be putting out the report to kind of make these decisions on their own. These are just guidelines. The basic guideline is take your range, divide it by how many classes you think you would like to have. That gives you an approximate class width. From that, you should augment that class width to a reasonable number. Like I don't even like the example of 2.5, to be quite honest. I would have done a class width of probably 2 or 3, but I wouldn't have done 2.5 because, as a human being, when I look at these numbers, my head hurts. I'm like, that's just terrible. Don't do that. I would much rather see whole numbers for my classes. So, I would have said, you know what, screw it. I'm going to do my class of 2. And if my lowest number is 17, then I'm going to go 16 to 18 and then just go up from there, and then, 18 to 20 and blah, 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 until I get to the top, which contains 42. And yes, they wanted to only have 10, but the reason why they needed the 11th was because they started their earliest class quite a bit below 17. Instead of starting at 17, they started at 16 and a quarter. Why the hell did they start at 16 and a quarter? I don't understand that at all. That makes no sense to me whatsoever. If the smallest number was 17, that's just stupid. Why start at 16 and a quarter? Now, maybe there's something more to this in the question, from previous readings. But even if, 17 was a rounded thing and 16 and something, I don't care what the reason is. These are, in my opinion, crappy class intervals. But again, that's my opinion. Other people think these are totally fine. So that's why you're going to see a lot of variability here. So all I'm going to tell you is this. What matters is that your class widths all have to be the same and that your classes are set up in such a way that they contain all of your data. Above and
Okay.
beyond that, everything is up to you. Now, of course, when it comes to the homework questions, the only other thing you have to worry about is following any instructions like creating one using 6 or 7 categories.
Okay.
And then that's it. Don't worry about where should my class start. Who cares? As long as it's smaller than the smallest number and you have 6 or 7 categories that end up being big enough to contain the largest number, right? So that, that's all that matters. And I guarantee you yours will look very similar to everybody else's because based on those rules that the lowest class has to be small enough to contain the smallest one, and the largest class has to be large enough to contain the largest one, and then you're going to cut it up into 6 or 7. Guess what? Yours are going to look pretty damn similar to everybody else's. And if you use the added, now remember, this is not a rule, this is just my own preference, and I think most people agree. If you use the added preference of starting your classes on nice, pretty whole numbers, like I'm not going to start it at 703 if my lowest number is 703. I'm going to start at 700, that kind of idea. And I'm not going to make my class width 27. That's just stupid. I'm going to make it 50 probably if my numbers are in, hundreds of things or even 100. Those types of things are pretty commonly used. But other than that, those are the only rules. Does that answer all of your questions?
It does. It kind of takes some of the pressure off. So
Yeah,
thank you.
yeah. I know it's very easy to overthink this stuff, especially since you guys are, doctoral level students, but I'm here to simplify them. Okay,
All right. Thank you.
Micah.
Dr. McBride, it's on the same question, and I'm to the point where I have completed the computations to make the relative frequency table, and now trying to create a histogram from that. Am I using the data that was uploaded in SAS to create the histogram? If so, I think I'm doing it incorrectly.
Are we talking about 3.54 still?
Yes.
Okay. So with 3.54, the only way to make your histogram look halfway decent is to use the code that's here in our document. But you don't have to do that to at least do what the question asks. So if we put in 3.54, run that, then go to our graph histogram, right? And then now I've got to change it to import one. Pick my analysis variable, which is damages, right? And I can do count or proportion, right? Whatever I want. In this case, I think we're just doing, we can start with percent. Now here's where you can do some augmenting here, right? So for bins, you can specify the number of bins, and you can go ahead and say, all right, let's try it with 7, and let's see how it looks. And that's about all you can mess with the menus. And you can see that when we tick this off, you can see what happens to the code. It goes away. And if you click on here, you can see that it adds n bins for number of bins and then equals 7. So if we just run this, let's just see what it looks like if we run this. Pretty crappy, right? It's supposed to have 7 classes, and you can
Right.
barely even see these classes, right? They're there, but they're not great. So that's where, if you want it to look better, you're going to have to do some coding. Now, if you submitted this, fine, I'm fine with it. You follow the instructions and you got something with 7 classes. You shouldn't be happy with yourself, though, in my opinion, because that's a crappy histogram. You could very easily make it a lot better by just using some simple code, right? And in fact, if you look at this, the only code that matters is what's going on down here. Now let's see, this main proc is sgplot. Let's see what our main is. If we go to back to our code, see it's sgplot, right? Proc sgplot, and then the data is already put in for import 1. So I really don't have to mess with that. What I can do is I can just copy this line and put it in front of it. Control C, right? So I'm going to go here. I'm going to say edit, which is going to create a new program because now we're going to mess with it. And I'm going to put it here. It really doesn't change it much, just changes the width and the height, which really wasn't that important. And then I'm going to come down here and I'm going to leave my proc SG. I'm going to leave that alone because it's already changed to import 1. And all I'm going to do is I'm just going to copy all this. Control C, come down here and highlight all of this. Control V. And now let's run this, see what this looks like. Oh, what I get? Fluoride. Oh, fluoride. That's my problem. What's my variable?
Damages.
Thank you. So code. There we go. All right, let's try this. Well, that looks great. All right. Let's try the whole thing. Let's just clean the whole thing out. Get rid of everything else. Come on. Okay, mine's an import 1. Damages. Was it import 1? Yeah, it was import 1.
Just glad to see. I've done this like 5, 6 times, and this is what I kept going through.
Maybe it's the capital
I know
D.
that's not.
Let's
no.
try that.
Mm-mm.
I think it has something to
The
do with
bin start needs to be like threes.
No, it's
300
not that.
issues.
It's the
Right.
graphics. It's the graphics stuff.
Oh, okay.
I think this needs to be there. All right. Nope. All right, let's go to my programs, histogram, see what's different. Why is this fluoride? There was a different question that did fluoride. Oh, this one is 3.54.
3.4 had make the histogram for fluoride.
Fluoride, yeah, so this one I did it for fluoride. All right. So it is damages. Histogram damages. All right, let's work with this one. And let's just put in this. See what that gives us. And get rid of the end bins. Bin start statement is not valid. Oh, that's why there's no semicolon there, because it's all one. It's all one command line. Son of a biscuit! What the hell? This was working before. I don't know what to tell you guys, and I don't want to waste any more time on this. This is really starting to friggin' piss me off. Does this one have fluoride?
Can we look at the one then with fluoride? Because I was getting the same experience. I was trying to do on 3.54 with trying to add the code into the fluoride one too.
All right. Well, let's try the one with fluoride. All right, the only thing I have to change on this one is fluoride is import 2. So this should be import 2. All right, so I don't know why the hell the other one's not working. So difference between that one and this one. Sorry. All that's changed is import 1 and damages. And this is not there, so we can get rid of that. Did you guys hear that?
Would that be the Ohio State Alabama game?
Yeah,
Oh.
my wife is a Buckeye, so
Oh.
she's very excited.
Yeah,
Guys, I don't know why
minute.
this isn't working. I'm thinking it's got, let's see, what's the log, ODS statement. it doesn't seem to have a problem. The number of histogram bins computed for the specific bin operation exceeds the current maximum. I'm thinking it's oh, you know what? I'm so sorry. I think somebody said that. It's because my bin width numbers are all screwed up on this one. That's what it is. Damn it. Where is the data? 3.54. So what's our smallest number? 361?
Yes.
Okay. So let's go. That's what it is. Damn it. Code. It's so instead of 361, let's start at 300 and let's do a bin width of 100. Oh, thank God. Oh, so there it is. So there's a start, right? And then that's pretty crappy because there's so many of them. So you could go, okay, maybe a bin width of 200. 1, 2, 3, 4, 5, 6, 7, 8, 9-ish, right? They want 7, right? So if we did the math, what was the bin width?
262.3 is
262. All right, so let's just make it 300. See what 300 looks like. That's pretty good. I'd go with that one.
That looks pretty good.
Yeah. So there we go. Figured it out. I'm a moron. That you got to make sure that your numbers here, match with what you have. And God, I should have read the log before because it had down there in green. It was telling me what was wrong, and I think one of you was even trying to chime up and tell me what was wrong. So I apologize for cutting you off. But there it is.
I'm
Those.
glad that we walked through that because that helped me to understand kind of more what those things mean.
Yeah.
Thank you for going through that.
Of course.
Thank you.
I'm hoping that my embarrassment will at least teach you something.
It taught me.
No, I think troubleshooting it, like when you run into those kinds of things, is kind of tricky, at least for me, because I'm new to this. So I.
Oh yeah, totally, absolutely. Yeah, I mean, we learn from our mistakes. I will never make this again. So we all learn much more vividly from our mistakes. Okay, what other homework questions you guys want to go through? Oh, sorry, somebody said stem and leaf plot, right?
Yes.
Okay, so we can't do stem and leaf plots in Excel. Well, I'm sure Excel can do them. I don't know how to do them well. I would have to Google it and find a video or something that tells me how to do it. But so here's our data from 310, right? Because we have to use 310 to do stem and leaf plot. And then if we go, I'm just going to open up this program here and just get rid of it. And we're going to do stem and leaf plot. So if we come down here, this is the code for stem and leaf plot. And what it does is it just turns the graphics off, because the graphics program, if you run the normal proc univariate program, it gives you all these nice displays, and one of them is a stem and leaf plot. But when the graphics are on, it comes out as like a bar graph or something. You have to turn the graphics off, and then it shows you a stem and leaf plot the way it's supposed to be. So if we just paste this bad boy in here, and the only thing we should have to mess with this code is where it is. And I just put it in import 3. So if we change this to import 3, this should now give us what we need. There's our stem and leaf plot for 1985. There it is for 96, and there it is for now. The stem and leaf plot is just this stuff. It's not these things over here. These are telling you how many are in each category, which is some nice, information to have. But as far as a stem and leaf plot is concerned, it's just these numbers, right? Here's your stem, here are all your leaves, all nice and pretty in order.
That helps a lot, because
Yeah.
what happened, like I found a couple videos on Excel, but what they do is they back it up. So I thought maybe there's a way you could do like back to back on 3. Now you can do it in Excel, no problem.
Okay.
That helpful, thank you.
Yeah, sure.
I had a
And guys,
question on that.
yeah, go ahead.
Oh, do we have to do number 311? Because I didn't see
Yes.
it to do in the assignments. It only has 1, 4,
It's-
10, 24, 54, but in the file for that week, 311.
If you look again, it should be there because I went in and added it a couple days ago because something happened between the summer term and the fall
Okay,
term
so
and
let's do
the
311.
course master. They changed it and the assignment no longer lists
List that one. Okay.
that one. Yeah, so I'm pretty sure I changed it on all 4 sections. If you go in there now, it's got 11 there where it didn't have it a couple days ago. So yes, please do 11. It's important because it makes you do a stem and leaf plot. So
Okay, because I saw in the notes too, it had stuff on to do a stem and leaf plot, and then I'm like, well, I don't know. Okay,
yeah.
but that seems simple. Okay.
Anything else?
Hi, can you go over 3.1 letter C?
Sure. So letter C is a bar chart with percentages. All right. So 3.1. Run this. Oh, we want with percentages. So there, it depends. So I think your guys's data is what mine is called edited. I've got 2 sets of data up here. That was the old original 3.1, and then there's a new 3.1, which I'm pretty sure this is the set of data that I put in the Google Drive for you. So if you load 3.1 now, it should have the program, the expenditure, and then the corresponding percentages for each of those expenditures. If it doesn't, then you're going to want to take your 3.1 data, put it in Excel, compute the percentages for each of these programs. Very easy. Just take the number and divide by the total, right? And there's your percentage. And then create a new column percent and put those things in there and then upload it, because you need that data to make some of these graphs. Although I think they've changed their interface now that you don't even need this anymore. All right, I already ran it. Okay, so it's in number 5, and part C is to do a bar chart. So we go to tasks and we go to bar chart, and we want to run this on number 5, and we're going to run it on the expenditures, and let's just see what that looks like. Wow, right? Because when it looks at the expenditure data, each one of these numbers came out once, and we don't want on expenditures. That's stupid. We want it on program, but it's going to be the same thing because we run on program. They also come out once because each one of these data values is only showing up in your data set once. So what you need to do is, instead of measuring the frequency count, i.e. what it is in the data set, you need to measure by a variable. And then the variable you're going to use is expenditures. And now if you run it, the heights will all be corresponding to their expenditure amounts, and they look like what they're supposed to look like. And then, of course, if you want to do it for percentages, you just change the variable from expend to percent, and you get the exact same graph, but it'll just have percentages over here instead of numbers. Does that answer your question?
Yes, it does. I didn't have the percentage column on it. I downloaded it straight from the Canvas, and it didn't include the percentage. So that's why it was a little confusing.
Yeah.
Thank you.
Of course.
Can I ask a question? On these graphs, do you want us to put titles and all of that, or do you just want the basic?
Either is fine. This is completely acceptable. If you want to play around with it, put titles in it, make it look pretty, that's just great practice. But I'm glad that you mentioned this because please, 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 for my own sanity, do not snip everything. Just snip this, right? Just take that little bit and put it in your Word document. Don't do like the whole page. Don't do, this whole window. I don't need to see this crap. I don't need to see this stuff, because when you do that, these things just get smaller and smaller and smaller and harder and harder and harder for me to see what you've done. So in your homeworks and in the mini project and the final project, please make sure that if you're doing any graphs, that you're snipping just the graphs, right? You're taking just those pieces and putting them into Word, not the whole darn thing. In fact, they even have you download results as a PDF. They used to have it where you could click on this little W and it put it in a Word doc, but I don't know. You can try this, but I think it still downloads too much stuff. It's better just to
It
snip.
does do the Word. It's just that when we put it inside the assignment on the page that you have for the homework, you will just have to sometimes use your to make it bigger, because every time I make it small, my numbers get small, and I'm hoping that you'll be able to read it, but you'll have access to pull the chart to make it big or small when you download it.
Yeah, that's the best way to do it, is to make it big, right? So I can read those numbers.
What about,
I have a question about one of them. Excuse me, my apologies.
No, go ahead, Montrese.
It's for 3.24. The small question that I do have is, I know it asks for the mean, median, mode for the 30 measures, and then it asks for it separately. I just want to make sure that I'm doing it right, because I think I did it correctly. But what is the difference between when it's asking for just the 30 measures and then when it's asking for it separately?
So separately means you have to do it by group. And we did that earlier. I think it's gone, but oh, here it is, summary statistics. So if you run this, you have to put in the classification, put in the group classification, and then when you run it, it gives you the mean, median, and mode for each of the 3 groups, group 1, group 2, and group 3. So that's what it means by separately for the groups. And then when you take away that grouping variable and run it again, this is the mean, median, and mode for the whole set. But you also have to, be careful that some of them might have multiple modes, and they don't show up in SAS unless you put in the extra code that I provide.
Got you.
Up here.
And the branch off question for that is, I tried to use the zip file and I can keep doing it the hard way, but how did you get it to upload to the system? I had to keep going in and separately download. I tried to upload my zip file, but it's not letting me.
If you download the zip file to your computer, then you have to unzip it, right? You have to open it up and extract all your files to one folder. And then when all of your data files are in one folder, then when you go to the upload, you can go to that one folder and highlight all of them, and it'll upload all of them all at once.
Okay. Thank you.
Yep. Anything else? I thought Jacqueline or somebody had a question, and then we kind of stepped on it.
I think with the homework, like you were saying, just put the simple, just paste there. Same with like a couple of them ask for like the range. Do you want me to like spell out like 1.03 minus this equals this, or just put the range?
You could just put the range.
Either.
Yeah.
Okay. I was putting in like how I did it. But.
Which is fine. More information is always great. If you show your work, that's fantastic. Just make sure that, it's bold or something so I can actually see where your answer is. But yeah, that's fine.
And then I was stuck on 3.4C. I got the range. I was able to get the frequency histogram, but for some reason when I was doing the relative frequency, I couldn't get it to look nice, but I don't know. It was what you did earlier, so I haven't went into.
So you want to plot relative frequencies. Okay, so 3.4. 3.4, I thought I already loaded. 3.4, there it is. Import 2.
Jackie, what I did, because I had the same problem, in the code, change count to proportion, and that should give you a nice graph.
Nice one. Okay.
Yeah.
I figured it was one of my days.
I struggled for about 2 hours, and then I realized,
yeah,
oh my gosh.
Yeah.
Okay.
Yep. Oh, yeah, back to the whole fluoride problem.
Damages, yeah.
Yeah.
Yeah, that was a couple hours on my.
Yeah. 3.4 is fluoride. I'm in the wrong import. It should be import 2. That's what it is. Import 2. There you go. So that's the relative frequency histogram. And it should look pretty much just like the other one. I mean, they'll be identical. Your regular histogram and your relative frequency histogram will look identical. The only difference is the scale, right? One scale will be proportions and one scale will be numbers.
Okay.
But the bars will all be the exact same sizes as they were for the two.
Okay.
All right. Anything else?
I don't think I have any more.
Okay. All right, guys. Well, it's been fun. Cecily?
Oh, no, I actually did not mean to hit that. I was getting ready to get myself together and watch Alabama beat up on Ohio. I know that's unpopular.
Yeah, sorry, you just got a 0 on your homework.
You're gonna
It's nice knowing you,
for
Cecily.
the rest of the year.
No, there's no point in even, don't even bother submitting anything. You can stop submitting work. You're getting an F, that's all there is to it.
No, roll tide. I have to rep. I have to rep here in
Wait, let
Alabama.
me guess. You must be a Steelers fan too, right? No.
A Steelers fan? No. Oh, God, no.
No, okay.
No, any Alabama fan must also like the obnoxious Patriots, and now, of course, the new the one that Brady's Tampa Bay.
Oh, I am not a Patriots fan.
Yeah, the Buccaneers.
I am
Yeah,
not. Oh,
so those people go hand in hand.
Oh, far from.
All right, guys, enjoy the game. I'll see you all on Wednesday.
Thank
Everyone
you.
very
take
much.
care. Be safe.
Good night, everybody.
Thanks.
Bye.
Bye.